This is Physics 813, and we're going to start with Lesson 1. If you haven't printed out Lesson 1, you should probably do that. There's the first main page. We're going to be looking at some things on that. We're going to be figuring out how to use our circuit board and the meters to measure resistance, voltage, and current. So what I'm going to do first is to show you how to read the color code for resistors. It is in the book, but I want to explain a little bit about that. And then I'm going to use a resistor different than the one you're supposed to use, and we'll go through and make the appropriate measurements. So when you're trying to figure out the resistance for a resistor, the first thing is that you should notice resistors have 3 color bands on one end and 1 band on the other end. So the first band is a digit, the second band is also a digit, and then the third band is what we call a multiplier, or times 10 to the some number. And this will give you the resistance. Now, the single band at the other end can be either gold or silver or no band. So this tells you the accuracy of the resistor, because even if you have a number, a particular resistance based on this number, the actual resistance probably is not that exactly. So gold is within 5%, silver is 10%, and no band means within 20%. Most of the resistors, actually all the resistors that we're going to use will have a gold band, so the actual value is within 5% of the color code value. Now, we could also just memorize these numbers, but I really don't like memorizing a bunch of numbers. So I'm going to show you a way to figure out the color code. Obviously another way is just to write it down somewhere and refer to it. But we're going to start with the absence of all colors, which is black, and we call that BK. I'm not sure if anyone uses BL, but BL could be confused with blue. So normally we use BK for black, and then we go to brown, then we go to Roy G. Biv, except minus the I. So we have R, O, Y, G, B, V, and we still don't have quite enough colors, so we're going to go with gray, which is GY, and then white, which is W. So that will give us enough colors, and then we start up here and go with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we will have the 2 colors here. This will give us 2 numbers, then times 10 to the third number. Notice that this is not scientific notation. Scientific notation has a decimal after the first number. So this is not scientific notation. Okay, the resistor that we're going to use is yellow, violet, orange. So if we look at yellow, yellow is 4, violet down here is 7, times 10 to orange is 3. Now most of the resistors that we're going to use, well, some of them, will have a multiplier of 10 to the third, which is kilo, so that we can refer to these as 47 kilo ohms. And much of the time we don't really say ohms, we just say a 47K resistor. If this happens to be a 10 to the 2, which would be a red, and I think there's a red, one of those in one of the later labs, but then you could have written as 47 times 10 to the 2, then moved the decimal over and made it 4.7 times 10 to the 3, which would have been a 4.7K. So much of the time we try to move the decimal to get this into K for kiloohms if it's fairly large. Otherwise we might just call it like a 47 ohm resistor. Okay, so once we figured out how to read the color code, now we need to start using the meters and the circuit board to figure out resistance and voltage and current. So what we're going to do, I also wanted to mention that we have two students. I have one operating the camera and another one sitting in from time to time. So if you hear voices other than mine, it's from them, and they have been instructed to tell me if I get my hands in the way where you can't see, that they're to let me know so I can move my hands. So if you hear them, that's what that is. Okay, the resistor that I'm going to use is this 47 kilo ohm resistor, and it's a yellow, violet, orange. So we need to figure out the actual resistance of it. Now, we have 2 meters, so if you want to, I think I will leave the meters here for the moment so you can focus on the 2 meters. You will be measuring, sometimes you'll be measuring current and voltage at the same time, so you're going to have 2 meters, so you can have one for current and one for voltage. Both of them generally measure lots of different things. I've tried to be somewhat consistent to have you use, say, the orange meter for voltage most of the time, and I call this the yellow meter to measure current. You can measure resistance with either of these. I think my instructions say to use the yellow meter. Okay. Now, we have 2 what I call double banana plug wires, and they will go into the meter, but then we also need the other end to clip on the resistor. So we have these alligator clips that will clip onto or push onto the bananas. So I'm going to put those on here. So we have this. Then the other ends are going to go into the meter. Obviously, I think you realize the color of the insulation really isn't relevant to the circuit itself. The color is mostly for people to kind of keep track of what they're doing. So I will use the black one and put it in the hole that says common. So generally we will always use that hole. So I'll put that kind of out here. And then you notice there are 2 other holes. One of these is to measure 10 amp current, and I don't think we're ever going to use that one. So on the other hole, it will measure voltage or ohms or milliamps. And I want to point out that this meter, you don't have to change holes if you're going from voltage to current. On the other meter you will, but I think I've got most of it, the currents on this meter. So we're going to put the red one into here. And then for this meter, actually maybe, okay, can you see the dial here? This meter does not have an on-off button. It has an off position, and then you move it to whatever you want to measure. So we're going to measure resistance, which is in ohms, and you have to look around here and find that over here is the ohm symbol. It is the Greek letter capital Omega, and there are several different positions that we could use, and usually I will tell you which position. And so on this one we'll probably use the 200K position. So this would measure up to 200 kiloohms. Now, on the board, we found out that this resistor should have around 47 ohms. So 200, or 47 kiloohms. So 200 kiloohms would be sufficient. If we put it on the 20 kiloohms, that's not enough. So we put it on the 200. So I'm going to clip across here, get these untangled. And on a resistor, it doesn't matter which end you clip to which. So I'm just going to clip here. Actually, I'm going to clip to this side, and then I'll clip to this side, and then we'll read the meter. So sometimes it flickers just a little bit before it settles down, but this is 46.4, and that's very close to our 47. If it had been a lot different, then we would either have not read the color code right or something would be wrong. But this is sufficient. So I'm going to write this on the board. So 46.4. So 46. So our actual resistance is 46.4, and it was on the kilo ohm, so kilo ohms. So that's our actual resistance. Now, something else that I want to mention, probably not very often, but here at the beginning, when you're done with the meter, then you should turn it off. The batteries last for quite a while, but there's no reason for them to be sitting on for an hour or two. Okay, so I'm going to turn this back to the off position, and I think I'm going to leave those leads plugged in. I'm going to remove the resistor. Now, our next goal is to measure voltage. So now we're going to go to our circuit board. It's called a powered circuit board. The number is PB505. So sometimes I will refer to it as PB505, sometimes circuit board, and I think I also abbreviate that to CB in some of the activities. You'll notice there are lots of knobs and dials and places. I'm not going to explain all of them now, but as we need them, I will explain. So what we want now is to be able to apply a voltage to our resistor. If we had a simple little power supply, we could just simply hook in the wires and apply this. But we're going to do it on the circuit board so you can get used to using the circuit board. Okay, you notice up here in the upper right hand corner there are 4 terminals. The one on the right says GND, that's for ground. We will almost always be using that. There's a blue one that says negative voltage 1.3 to 15 volts, a positive voltage 1.3 to 15 volts, and then a positive 5 volts. Most of the time we will be using the ground and the positive, I just call it positive 15 volts. The 5 volts is if we want 5 volts exactly, and most of the time we don't. So then we have to figure out how to get the voltage from these 2 terminals to our resistor and how to adjust the voltage. So our adjusting knob is this one, and notice you'll be able to see it. It says positive V, and if you can't see the positive V, that's okay. They can see it. So this knob, if you turn it completely counterclockwise, that's down as low as it'll go, which is about 1.3. I think I found it was actually about 1.2. And then as you turn it up, you can get up to about 15. Now, without a meter in here, you won't be able to tell what the voltage is. So we're going to connect our circuit and then apply the voltmeter, and then we'll make our adjustment. There are lights here, and there's a little switch which is right behind here to turn it on. Be sure it's plugged in, that's the first thing. And then I usually get my circuit connected on the circuit board and then turn it on. So I think that's what I will do now. Okay, I will have sent with you a bunch of these little wires. I call them, sometimes they're called jumper wires or just wires or leads. we have already stripped the ends. Now I'm also going to send you some wire and some strippers so that if you need a different length than you already have, you can make one of your own. So I'm going to start with the ground wire, and you unscrew this a ways. Now it does have a hole that you could use a banana plug in, but I wanted to use these smaller wires. So you unscrew this up a ways, and then you'll notice underneath there's a hole so that this little wire can go either direction. And since I want it to come down here, I'm going to put this in so that it comes through this direction. And there we go. So I put it through, and then I will screw this down, and then you can see the wires there. Now, it needs to go into some of these holes. So in this circuit board, you have to kind of know ahead of time what's connected to what. And the rule is that the holes in a row are connected underneath. There's a space through the middle, and so one side is not connected to the other side. These holes along the side, they are connected. I think that this set is all connected, and then this is a separate set. Generally, I don't use those. If we do use those, I will let you know for sure what all is connected. So usually we just use one of these regions here, and it doesn't matter. So I'm going to just put this into a hole. It should fit fairly snugly, and I think I have watched, and all the wires that I'm sending are small enough that they fit in there. If the wire is too big, then it will damage the circuit board. So we've got our ground wire there. Now we need a positive wire. We're going to use the positive 15 volts. So this is this one. So we'll unscrew this and insert this, and then screw this back down. You might want to make sure that when you're putting this in, you don't put it in so far that the terminal screws down onto the insulation, because it might not make good contact. So I usually try to, once I get that in there, there we go, to have it so that I can still see a little bit of the bare wire on this side. Okay, so we're going to connect it over here. And remember, it's the rows that are connected to each other. So I'm going to put this up here somewhere. It doesn't matter which one of these holes I use. So I'm going to just use one of these here. Let's see. Okay. So now we have a voltage applied to this region, but we need our resistor. So I'm going to put the resistor, it doesn't matter which end you put which direction. I'm going to put it in, kind of push it in there, and then my other one goes in the same row. I'll move that over kind of to the side. Notice that the ground wire and the resistor wire are in the same row, and our positive wire and resistor are in the same row. That's one thing you're going to need to be careful about. It's very easy to get them not in the row that you want. So if your circuit doesn't work, check that first. Okay, so now I have this connected. We're going to measure voltage. So we're going to use our orange meter, and we're going to use the black in the common, which seems to be over here on the right. And then this one has a different hole for measuring current than voltage. So I think we're going to mostly use this one for voltage. So I'll put the red one in there, and I'm using my other set of double banana leads. I left the original set in the other meter. I'm going to add the alligator clips to here, And then I'm going to go ahead and connect this to my resistor. Often it doesn't matter whether you get a positive or negative. We usually just use the positive value, but I'm going to try to show you so that it'll come up with the sign that we want. So for this black one, I'm going to connect it over here to the same side of the resistor that went to the ground wire. And the red one I'm going to connect on the other side of the resistor so it goes with the other red wire. Now, on this one, it has a power button. So I'm going to put it in the right position first. Okay, can you see these? Okay, so notice that we have voltage. We actually have two voltage positions. The one with the wavy line is alternating current, and we're not using that, at least now. So the other one that has a straight line above it, actually it has some dots above it, that's the one that we want. And generally I will tell you what position to have this. We're going to want about 4 volts. That's basically what I've decided that we would look at. So we need to have it on the 20 volt setting. So the little arrow here, you have to watch, it's kind of hard to see, is pointing to the 20 volts. So we're going to push the power button, and it comes on, but it says 0. And then we remember, I haven't turned the circuit board on yet. So if something doesn't work, check to see that your circuit board is on. So I'm going to flip the switch over here, and we have the 00 there. That mostly just shows that it's on. Notice that I've got this knob turned down as far counterclockwise as it'll go, and that it's showing about 1.26 volts. So for some reason it really won't go down to 0, so that's okay. Now, since I said, let's see here, I wanted to adjust this to 4 volts, so I'm going to turn this knob and we'll watch it go up to 4. Now, it's very difficult to get it to be 4 exactly. I'm not sure that I have ever got it to be on 4.00. So when you're doing one of the labs and it says adjust the voltage to 4 or to 8 or whatever, it doesn't have to be exactly that. Most of the time you will need to record the exact value, but it doesn't have to be exactly what it says. So let's see, you just barely touch it, and if I wanted this to be 4 volts, I would prefer to see a 4. So I will turn it so that we have a 4 here and then just slightly more than 4. So it will fluctuate a little bit. Right now it's showing 4.00, but in a little bit it will probably change just a little bit. Okay, so we have our 4 volts. So I'm going to write that on the board. So our voltage is 4 volts. You should notice V is for voltage, the variable. V is also for the unit volts. And when you write down, when you record any numbers, you should have the units with it. I'm fairly particular about that, because if you don't put a unit with it, no one knows what you're actually recording there. Okay, so we have our voltage. Now we want to measure current. One of the particular things about current is that current is a measurement of the flow of charge through the circuit. So like your electric meter and your gas meter at home, the gas or the electric must flow through the meter in order for it to be counted. So for that reason, we have to do something a little bit different when we measure current. Normally, I'm not sure, yeah, I even say the circuit must be broken. The tendency is that you want to leave the circuit like you have it and then attach a meter that will measure something. And that's correct for voltage, but for current, you must break the circuit and insert the meter, make a measurement, remove the meter, and then close the circuit back like it was. So, what we're going to do is I'm going to break the circuit, and there's two places, on one side of the resistor or on the other side of the resistor. I'm going to choose to break the circuit on the side of the resistor that goes to the ground wire. So I want to keep my voltage, so let's see, what am I going to do here? I'm going to move my voltage lead a little closer to the actual resistor, and then I'm going to pull, I think I'm just going to pull the ground wire out. Well, there we go. Now, you could pull out the resistor and the ground wire, or you can pull out just the ground wire, or you can pull out just the resistor wire. So any of those works fine. So I'm going to pull out just the ground wire. Then I need to insert my meter, and I usually will tell you what setting to put it on. This one I have as 2 milliamps. So we need to find our current, which is over here on the right. 2M is 2 milliamps. This is 20 milliamps. This is 200 microamps. We might actually use that, but probably not today. So 2 milliamps. So let's set this at the 2 milliamps. And of course it should say 0 because this is not in the circuit. And then I'm going to use the black lead and connect to the black wire, the ground wire. So I'm going to connect there. And then I'm going to use the red one and connect to my resistor. Okay. Now, we do have our voltage back, and now we have current. So if you notice, it says 0.086 milliamps. So we have an actual current there. Let me put that on the board, 0.086. So our current is I, so we have 0.086 milliamps. Now, in the lesson, it tells you to change the scale to the 200 microamps. So I'm going to go ahead and do that. I can just do it while I've got everything still in the circuit. And then I end up with 84.1. Now my voltage changed a little bit, and what happens is in the circuits, because there's wires and various things, it doesn't stay exactly the same if you change some of the scales. I'm going to change this so that we get back up to about 4, okay, I've got about 4.05. And notice that our voltage is, or our current now is 87.4. But these are microamps. So let's write that on the board. 87.4 microamps. Now, if we notice up here, milliamps, if we were to change this to micro, milli is 10 to the minus 3, micro is 10 to the minus 6, so there's 3 decimal places. So if I change this, I would get 86 microamps. Now, on this one, notice that we get a third decimal place that we would not get if we were on the milliamp scale. Sometimes it's important to have that other decimal place, sometimes it's not. But with the microamp, you will get an extra digit there. Okay, so we have seen how to measure resistance and voltage and current, and once we're done with the current, then we should remove the meter. So we'll remove the meter, and then assemble the meter or the circuit. So we're going to put that back in so we have our circuit like it was. And at this point, you can turn things off. Now, I would highly recommend that you don't disassemble this circuit, because in lesson 2, you're going to be doing this very thing, finding current and voltage for a resistor and for a light bulb. And so if you leave the circuit assembled, then you won't have to put it together again. Although, if you take it apart and then reassemble it when you start lesson 2, that will give you a little bit more practice. So either way you want to do it is fine. So I think this will be the end of lesson 1.